All right, so today we're going to continue to work with polygons and angles and sides. And in your practice today, the first set of instructions that you're going to get are going to ask you to find the measure of each interior angle of the regular polygon. Those are the exact instructions. Now, regular means that all the angles are the same and all the sides are the same. Okay? So you're going to be finding the measure of each interior angle of the regular polygon. You're going to be given the polygon as a word, meaning let's say they give you a nonagon. All right? If you just look at that chart on page 394, a nonagon has 9 sides. So this thing has 9 sides. So we're going to use the same formula that we used yesterday, but we're going to modify it just a little bit. We're going to take that formula n minus 2 times 180, but we're just going to divide it by n. So here's how this works. If we take our n minus 2 times 180 and we divide it by n, which is the number of sides, it will be equal to each interior angle. So for this nonagon, we're going to take 9 minus 2. We're going to multiply it by 180. And then we're going to divide it. We're going to divide it by 9. And now it becomes a calculator problem. So 9 minus 2 is 7 times 180 is equal to 1260. And then you divide it by 9, get 140 degrees. All right, so the measure of each interior angle of a regular nonagon is 140 degrees. And you'll have about 4 or 5 problems to do just like that. So let's try it again. Into the deck. Let's try it for an octagon. All right, and an octagon has 8 sides. So the formula that we're going to use is 8 minus 2 times 180 divided by 8. So 8 minus 2 is 6. So 6 times 180 equals 1080, and then divided by 8, 135 degrees. So each interior angle of a regular octagon measures 135 degrees. Everybody okay with that? All right, the key is to take the description of the polygon, find out how many sides it has. All right, and you can look at that chart on page 394. Once you know the number of sides, you just plug it into the formula n minus 2 times 180 divided by n. Your number of sides is the n. So however many sides the shape has goes where the n is in the numerator and where the n is in the denominator. Okay? Then the second part of your assignment today, you're going to be asked or told the measure of an interior angle of a regular polygon is given. So they're going to give you the measure of one interior angle. The question is to find the number of sides. So in this case, we have to solve for n. All right, now here's the formula you're going to use. The measure of an interior angle of a regular polygon is given. So let's see what they give you. They give you 135 degrees. That's the measure of each angle in this polygon. We need to find the number of sides. So here's the formula that you use. You take the angle measure given, you multiply it by n, and then you set it equal to n minus 2 times 180. Angle measure given times n equal to n minus 2 times 180. So now you do the distributive property on the right-hand side of this equation. So 135n is equal to, we got n times 180, which is 180n, and then negative 2 times 180, which is negative 360. We're just going to solve for n now. So subtract 180n from each side. And 135 minus 180 is equal to negative 45n is equal to negative 360. And then we divide both sides by negative 45. These cancel, our n comes down, and our n is equal to 8. So if our n is equal to 8, that's how many sides the shape has if each interior angle is 135. If you're asked to find the shape, just use the table backwards. Okay, 8-sided shape is a octagon. Very good. So when they're asking you to find the number of sides, you take the angle measure given times n, make it equal to n minus 2 times 180. All right. After you do a couple of these problems, what you'll see is that this is the same every time. what I just circled. N minus 2 times 180 is always equal to 180n minus 360. So you can actually just start right here at this step and save yourself a whole step. All right, so let's try that once. Let's try finding the number of sides of a regular polygon if each angle measure is 144 degrees. So we'll take 144n and set it equal to 180n minus 360. Follow the same steps. Subtract 180n from each side. And 144 minus 180, negative 36n. Divide both sides by negative 36. And these cancel. We get an n that's equal to 10. So the polygon has 10 sides. If you're asked to name the polygon as well, go back to that table on page 394. 10 sides is a decagon. All right, any questions on either of those types of problems? All right, then finally, on the bottom of page 396, theorem 6.2, exterior angles sum. We talked about this earlier in the year, but we'll go over it one more time. The sum of the exterior angles of a polygon, of a convex polygon, one at each vertex, is 360 degrees. It doesn't matter the shape. The sum of the exterior angles of a polygon, always 360. Doesn't matter how many sides it has. So if we take a triangle, all right, we've got one exterior angle at each vertex. If I number these angles 1, 2, and 3, angle 1 plus angle 2 plus angle 3 is equal to 180. I'm sorry, 360 degrees. Angle 1 plus angle 2 plus angle 3. The sum of the exterior angles of a polygon is 360. So if you are asked, find the value of x, and you're given a polygon, and they give you expressions for all the exterior angles. So up top we got a 2x minus 5. And then a 3x plus 10. And I'm getting this off of the top of page 397 if it's easier to look in your book. 6x minus 5. A 2x. And a 5x. These are all exterior angles. One at each vertex. If you're asked to find the value of x, then all of these expressions added together will equal 360 degrees. So I'm going to combine all these x's first. All right, I'm going to start with the 5x right here. So 5x plus 2x is 7x. Plus 3x is 10x. Plus 6x is 16x. Plus another 2x is 18x's. And then we have negative 5 plus 10, which is 5, minus 5, which is 0. So when we combine all of our like terms for all these expressions, we get 18x. Well, the sum of those angles is 360. So if you divide each side of this by 18, then our x is equal to 360 divided by 18, which is 20. So your x is equal to 20. If all of these vertices were labeled and you had to find each of these angle measures, well, then you would just substitute the 20 into the expression for each angle measure to determine the angle itself. All right, so the sum of the exterior angles of any polygon is 360. Any questions on what we covered today? All right, then your practice is going to be on page 398, problems 21 through 24, and then 26 through 31. Page 398,